So the topic of this session is renewable wood energy for decarbonization and forest resilience. During this session, we'll hear from Mike Staudenmayer, the general manager with Northstar Community Services District, who's currently developing a wood energy project in California, as well as Tom Wilson, who's the president with Wilson Engineering Services, and he's going to be our technical expert on wood energy. First, I want to set some context for why the Forest Service is engaged in this and how we're engaged in this, and the particular nexus that we see for mountain towns. So our motto is pretty simple. It's caring for the land and serving people. While it's a super simple motto, as you can imagine, across diverse landscapes and diverse communities, it's a pretty complex role that we have in maintaining our public lands. So we're working hard to manage our forest, to maintain its resilience to climate impacts. It's increasingly difficult in the face of increased development around forested areas, drought, wildfire. And in our stewardship and our efforts to get ahead of the risks and still provide sustainable wood products, we're thinning our forests and harvesting trees. We're also responsive to executive direction in recent climate change policies put forth by the White House and USDA that support climate resilient communities, carbon stewardship of forests, local economies, biomanufacturing, and the bioeconomy. We support markets and local economies to bring wood into use, essentially. The forestry workforce, from the ologists to the resource managers to the loggers and the mills, are truly essential to helping us manage the forests and providing products into the future. We work to increase the use of wood in the built environment, like for building materials, replacing energy-intensive materials like steel and concrete. We're also working in other emerging markets for biomass and small diameter wood that are byproducts of our forest restoration work. We want to move away from the open slash pile burning and put the overstock of small diameter trees that are in the forest that are not serving us well, to put them to use. So we're working in the spaces of sustainable transportation fuels, biochar for carbon removal and soil enhancement, and other bioproducts, nanocellulose infused concrete. And we're excited about the role that these technologies will play in our low carbon future. Some of them are not fully adopted yet. Some of that is related to policy, some is related to science. And some of it is related to market demand. But we're making progress on those fronts. So what is a pretty simple, viable, long-proven technology are wood energy systems. These systems are designed for a variety of scales and can produce just thermal energy or power as well. While displacing fossil fuels and using a local fuel source, wood energy users are also supporting the health of their local forests. So just sharing this final slide from me, our Wood Innovations program is here to support development of projects. We offer technical assistance. That's through our National Wood Energy Technical Assistance Team, which Wilson Engineering Services provides that service for us. They're a great firm to work for. We work with a number of other excellent firms in this space as well. They're available to just have a chat about, initially what is wood energy exactly and why might it work for me. They can help with a feasibility study, fuel supply analysis, advise on some funding and incentives. Mike and Northstar talked with our tech team early on that helped support them in moving forward. And then we also offer grants to help support wood use in manufacturing. This specifically includes supporting wood biomass energy projects as well. We have grants of up to $1 million specifically under our Community Wood Energy program. And the lower rate is $300,000 grants, but you can ask for as little as $50,000. So those are some of the services that we offer. The grant requests for proposals for this program are usually advertised in October. We expect our next RFP to be announced next week, and we expect this program to be funded into the future. The Bipartisan Infrastructure Law and the Inflation Reduction Act have been really generous to these programs and made these investments in healthy forests and the bioeconomy. So I would say get it while it's hot, because that funding is pretty abundant right now, and we're willing to help. So I guess in closing, I just want to say, we believe that our forests and wood are essential to our healthy climate now and climate future. We're partners, we're at the table, and we're in the field. And I guess sort of inspired by the talk we heard this morning, I would say, we will be part of getting it right. The Forest Service is at the table, and we're here to help. So with that, I will pass it to Tom Wilson, our resident technical expert on wood energy, and explain a little bit about that.
Was that a pun about the hot, get it while it's hot? Yeah. Burning wood? I'm Tom Wilson, Wilson Engineering Services. We also have a sister company, West Energy and Environment, and that company trades us feasibility studies and work in trading carbon credits, marketing carbon credits, aggregating carbon credits, or other thermal energy credits. We've been doing this work for the Forest Service since 2009. It all started on a trip to Austria when the Forest Service was looking for avenues to find additional markets for low-use wood products that were coming off from mills or clearings from treatments on forest lands. They were looking for markets, so it was less expensive to get those products out of the forest. And then I guess as it evolved a little bit, we were more looking at national forests and how we could do something with the beetle kill and the other things that needed to come out of the forest in order to reduce wildfire risk and maintain healthy forests. So our sister company does a lot of decarbonization work. We call it truly is just energy efficiency. Like, how do you reduce the amount of thermal energy generally that go into processes or for space heating or for whatever those uses are. and so there's some general rule of thumbs. If you centralize equipment, it gives you economies of scale when you buy a boiler that can serve multiple buildings or loads. It's a lot more economical than when you're just trying to service one building. It typically drives down long-term maintenance when that happens, and there's often renewable energy opportunities there, like back pressure steam turbines or ORC systems that can make, from waste heat, can make electricity. Another kind of central theme on thermal energy when you're trying to decarbonize is drive the temperature down. Like, don't take 180 degree water in to heat a building when you can do it with 140 degree water or 120 degree water. Don't make steam when you can do it with hot water. So you have to look at the total life cycle costs, the carbon costs for total life cycle of projects that you do. Typically on boiler programs or wood energy programs, we're talking about 30 years or more as far as the life of those systems. And every system or every approach has a weakness and a strength. I think you try to match those up for practical solutions for businesses and communities. So what are the options when you're trying to reduce your carbon footprint? And you can see that like electrical resistance heat is very efficient, but it's also one-to-one, like you put, and it's very expensive. Propane, fuel oil, all those things are on the upper end of the cost scale. Renewable energy, gas, like if you make biogas from anaerobic digestion, you have a very low carbon footprint, but you have a very high cost. So wood energy really fits in well here, because if you look at wood energy, and we'll go into this a little bit in the next couple slides, but wood energy is very low impactful as far as the overall carbon life cycle when you compare it to what happens to those products in another life if they're not used for wood energy and offsetting some fossil fuel energy. We commissioned this work from a company in California that does greenhouse gas accounting. And what is interesting about this slide, if you look at the first 8, I guess, representations on there, they're all wood energy. And the negative side, look what happens if you don't use that in heating or some renewable energy to offset fossil fuels. What happens if it goes to a landfill? You have the same carbon releases in the landfill as you would if you burn it. Sometimes you have higher emissions. What happens if it turns into a forest fire instead of getting those things out of the woods, those products out of the woods? The emissions are way higher than if you use it to offset greenhouse gas, fossil fuel. So I think, there's always been this in the environmental movement about negative for burning wood, but what are the alternatives? If you look at the life cycle of wood energy, that carbon is stored from the sun, and if you use it, then if it's maintained the same mass in the forest, it's generally considered to be renewable. And if you don't harvest it and you don't manage it, what happens to it? It ends up in a landfill from residual products. It ends up in a forest fire. It ends up in burning piles in the winter, and those emissions are way higher than if you manage it for a renewable resource. In the last, and this is a year old, this slide, but in the last 12 years, 13 years, and work we've done for the Forest Service, we've looked at 166 projects. Probably 2/3 of those have been implemented now. It's sometimes a lag time between when we look at a project and when it gets implemented. And if you want to reduce the carbon footprint, most projects cost money to reduce a carbon footprint. The wood energy projects that we've worked on and have been implemented, 112 of those 166 had a negative cost to implement over the life of the projects. So again, this is the logic for wood being a renewable resource. The wood stores solar energy that trees do. It has a life cycle. Some tree stands are 90-year stands, some are 120-year stands, some are 30-year stands, but they have a life. And at the end of that life, those trees are going to die one way or the other, and that carbon's going to go back into the atmosphere in some form. So a lot of people may or may not be familiar with modern wood systems, but in Vermont, it's been a real push, and that push is driven by economics, and the economics are that oil is the main fuel for heating in Vermont. And because oil is a very high cost versus natural gas or other or other energy sources, a lot of projects have happened there, and Vermont is a very forested state. So I'll go through a few simple projects. This is a project that was implemented in, I believe, 2010, 2011. It replaced fuel oil at a small school in south central Pennsylvania. It connected 3 buildings. It saves 60,000 gallons of fuel oil a year. They have $170,000 of annual savings, 210 metric tons of carbon dioxide avoided per year. The project it was about a $1.3 million project. It consisted of the new building and the upper left-hand slide. I guess it's upper left. It has an automatic wood handling system that's shown in the 2 lower left slides. And it also has thermal storage so that the wood energy system can modulate and not have to have peaks and valleys. I guess it's a $1.7 million project. Inflation. In New Hampshire, to heat the agricultural section of the University of New Hampshire, they put in a new wood energy district heating system. This system was fairly low cost, and the reason it was lower cost is there is a company in New Hampshire, the Vermont-New Hampshire border, that produces a dried uniform chip product that can be sold, and it's sold at a premium to wood chips, but yet it's very economical compared to making pellets, low energy. Holderness School in Plymouth, New Hampshire. This is a campus. It's I guess it would be called a preparatory school. They had a goal of 0 carbon emissions by 2021 or 2020, and this project helped them achieve that goal. We brought in from Europe 10-gauge steel piping that could be fitted and bent. You can see that in the upper right-hand corner. Reduced the number of fittings that were required. On campus, we connected 25 buildings, and there's 16,000 feet of underground piping. It has a $5 million BTU, similar size to what I think you're installing out in California. Wood boiler, same company. Messerschmitt produced this boiler, wood boiler. So as far as air quality and wood energy systems, These are actual measured emissions from emissions testing on the system. You can see in green is the wood, and you can see it compares very favorably on all the emissions, especially PM10, SOx, CO, and VOCs. So why would you want wood energy versus prescribed burns or other ways to handle that wood? And you can see the real issue here is emissions. They're so much lower when you can burn them in a controlled fashion. This is Peterborough Library. It's again it's a dried chip system, and they also do heating and cooling, absorption cooling. And this project's about 8 years old, I think. St. Benedict's, you can have any size and scale. What's interesting about this project is it's a monastery in Massachusetts that has their own school, and they are, I call them scroungers. They can come up with almost anything you'd want. They asked us how much wood they needed a year, and it was a very small amount because it was not that big a system or big a campus. And I think we told them it was about, I think it was 1,000 tons a year or something like that. And so here's what they came up with. They got donated this 40 ton per hour automatic hog system. So in about, 5 hours a year, they can produce their wood they need for their campus. They also got the local utility to bring them in. If you see the log pile on the upper left, there's enough wood in that pile for about 10 years. And they got all that done before they instituted their project. Even systems as down small as a cordwood system. This is a district heating system. Harvard owns a place called Harvard Forest where they do research on carbon capture and the CO2 in the air and the effects on the forest. They have I think it's about a 200-acre forest there. And so from down trees and trees they want to manage within that forest, they produce all the heat for their campus at Harvard Forest. So wood residues can be a useful resource for decarbonizing thermal energy. Thermal energy is one of the harder, and it's a lot easier to have solar panels for electric or solar or wind energy for electric. But when you get down to thermal energy, especially at higher temperatures and pressures, wood's a very effective way to decarbonize. Modern wood energy systems are clean, they're reliable, they're automatic, and wind energy systems come in all sizes and shapes. So again, contact Julie if you want technical assistance. They kind of direct us where we go. And so the first contact should be through her if you're looking at a project or you think you have a project you'd like us to take a look at, and she'll get in touch with us. Thanks.
Can I ask you a quick question?
Yeah.
What was the cost of the whole of this project? Do you recall?
Oh, was it on the slide?
Can you go back? Is that possible?
I think it was about $4 million, maybe. That's been 13 years ago, and I don't remember, but I can get you that answer. In fact, I can get you before the session's over. I can find the answer, yeah.
So I guess to that question, I don't know if that stems from just sort of trying to get a sense of like, what do these systems cost? I mean, they can be less.
So depends, like in the Holderness system, most of the cost there was hooking up the 25 buildings on campus, at least 60% of the cost of the project. Typically, a 5 million BTU an hour boiler that size, the building and the automatic handling system and everything in the supports it, emissions control, you're probably talking about 650 to 750,000 for the hardware, and then whatever a building can be, whatever you want in the building. But that gives you an idea of scale. And then there's the wood boilers that were showed there for cordwood boilers at Harvard Forest were about $30,000 each, I think, in that range. So.
Alrighty, Thanks, guys. I'm Mike Staudenmayer. I'm the general manager of the Northstar Community Services District. If you're not familiar with those special districts of California, we're kind of like a small town, if you will, minus the dog catcher. We serve one of the resort communities of North Lake Tahoe. Northstar, it's a Valley resort just north of the lake. And of particular interest in this topic is our fire protection. We run 2 fire stations and developed a forest fuels management program, which was kind of the genesis of us getting into the wood energy business. We weren't looking for something else to do. We were in this business. We were generating this byproduct. We needed to do something better with it. So I'm going to talk a little bit about how that came to be and how we got to where we are in terms of implementing that project. So it kind of started back in 2007. We had the Angora fire in South Lake Tahoe, which we thought was a pretty big deal at the time, and it was. 280 structures, 3,000 acres. It really affected the watersheds of Lake Tahoe and the water quality concerns that go along with that. And so I got to tour the site. By the way, I took all the pictures that you're going to see in this presentation myself. So we were able to tour this while it was still burning, and it really left an impact in me in terms of like, what can we do in our community to keep this from happening? And so that's kind of the genesis of it that I'll talk about. But then in 2019, obviously the Paradise Fire came through and just really set the bar a little bit differently in terms of multiple orders of magnitude of destruction and fatalities, and almost 19,000 structures and billions in dollars of loss. And so I, again, got to tour that fire on the 6-month anniversary and got a really heartfelt kind of, experience talking to the people that were directly impacted in that fire. And even when you're not directly impacted by a fire, just like we are today here in Jackson, the smoke from surrounding fires can really create a poor quality of life. This picture I took on the way to work one morning, we were wedged in between the Dixie and the Caldor fires, and this was a summer that we lost months of outdoor recreation and the ability to enjoy the area that we all called home. So, and then the tourists as well. You really couldn't experience it. So, obviously, we're doing this work to try to avoid these types of occurrences. So, like I said, after the Angora fire in 07 and 08, we decided that we needed to do something, and so we diverted and/or stole money that was kind of allocated towards our road maintenance program and hired a forester and started chasing grants. And since then, we've done over 2,000 acres of treatment in and around our community. We've leveraged that initial investment and received over 3 million grants. In fact, we got over 1.5 just this past year to go towards fuel reduction efforts. In 2021, we passed a parcel tax, just $219 a parcel per year, and that was passed at 88% approval, which is kind of nice. That allowed us to get our road money back, put the roads back together, and allow this program to kind of stand on its own feet. And the idea here is that we program this amount to allow us to get to what we call maintenance mode in a 10-year period. So this is a 10-year sunset on this tax measure. And maintenance mode basically means we're getting the forests back to where they should be in terms of an ecological health. Kind of, you've heard the stories of when Western migration showed up. You were able to ride a horse at full gallop through the forest because of the natural fire and the indigenous fires that would happen. Once we started putting out every fire, now we can't do that. We got to go in there mechanically and remove that. So in 10 years, we should be at that point where we just go in periodically and take care of the low vegetation and at a much lesser cost. Obviously, the forests, the state today, because of that suppression and whatnot, has resulted in beetle and disease and just overgrown. And when you have a fire, it gets into the ground and wipes out the whole forest. You guys have seen these pictures. The before and afters, we're just really just taking this low-hanging ladder fuel, this non-merchantable material. It's small diameter. It really doesn't have a purpose in the market today. and getting it out of the forest as best we can and getting it into that aboriginal state. But it creates this byproduct, the biomass, and so we pile it up over the course of the season of doing the work, and then we will burn it, generally right after the first snowfall. And sometimes, even this year, we're burning over 1,000 piles, and that is not a cheap. You got to exercise, you got to monitor that, and then it has its own impacts. This is actually a pile burning operation. You can see just after the first snowfall, and oftentimes these projects, these burning projects, kick off right after a precipitation event, which typically will put out the wildfires that we have. And so the community loves it. They've been dealing with wildfire smoke all fall, and as soon as we get a reprieve from that, because the first snow comes, we go out and we start torching piles. So that's not ideal, and obviously there's no emission control, and so let's just say it's less than ideal from that standpoint. And then it leaves scars in the forest floor, which isn't great. Yeah, we will do mastication, and then you've got the impacts of the heavy equipment roaming around the forest. We actually sparked a fire with one of these mastication units last fall. Luckily, it wasn't a windy day, and we were able to get under control. So, not a great solution as well. And there are projects. We did a project for the Army Corps of Engineers. They wouldn't allow us to move the biomass, and it was such an overgrown forest. We ended up with 6 to 8 inches of this chip material on the forest floor. It felt like a playground. It was really unnatural, and it's just sitting there. It's still fuel. It's still burn. It's not what was intended. So we get out what we can. This was a green waste recycling site we used to stick in one of the ski resort day skier lots. This pile here represents about half of a season's haul, which is typically about 750 bone dry tons. So if you can imagine a football field about 20 feet high with biomass, that's about 750 bone dry tons. And so this was less than ideal because spontaneous combustion would occur, and that's the last thing we need is to be responsible for a fire in our community because of the work we're trying to do to reduce that. But then, where do you take it? So chip and ship is the operation that we used to rely on, and we're having trouble in the later years trying to find a place to take it. And so in Tahoe right now, all the material, at least in the North Shore area, goes to a common transfer site, and it gets trucked, if there's a market for it, over 100 miles away, up and over Donner Pass, which is kind of crazy if you think about it, and comes at great expense. In fact, it costs the same amount to get rid of biomass in Tahoe that it does garbage, $15 a cubic yard. All those projects that Tom was showing you back east, they go out in the forest just to mine the wood to feed these plants. They don't have a forest fire problem yet there. And so they go out just to get the wood to mine these plants, and they pay up to $62 a bone dry ton for that material. And so we're treating ours like garbage, going into the forest for a completely different reason, but we need to do better. And so we decided we needed to figure out a way to reduce the impact, lower the costs, and do better what we're doing. So we did a scoping study, and I think it was 2019, and came up with this challenge statement, which I'll read. NCSD seeks to improve the economic viability, environmental impact, and overall effectiveness of removing and repurposing forest biomass in order to reduce wildfire risk and restore forest and watershed health. So, kind of triple bottom line stuff here, but we recognize this is not sustainable when it costs more than garbage to get rid of the material that actually has value. We're in this forever. This is not something we're gonna go and do and be done with. This management of the forest on our neck of the woods is forever. And so we need to develop those local economies to better utilize this byproduct and really close the loop. The disposal costs, like I mentioned, we're causing the cost of treatment to go from what we historically were seeing around $2,000 an acre to $4,500 to $5,000. We saw $6,500 this season, and a lot of that's due to trying to get rid of this material. So it is a problem. It's really eroding our budgets, our limited budgets to do the scope and scale and really meet this project or meet this this problem head on in terms of removing this material. So we hooked up with Julie in the U.S. Forest Service and Tom's company through the Wood Wood Education Resource Center that was mentioned. And she's not lying. It is truly free, pro bono work. We got a full-blown feasibility study. It said, okay, you guys have this type of wood. You have this amount of wood in the region. We did quality testing. Not all biomass is the same. And here are your opportunities to maybe put it to work in a way that can meet those project objectives in this challenge statement. And so we crystallized that into what is called a district heating system. Much of what Tom showed you, and I have a few slides as well, is been well established. This is not rocket science. It's not new technology. It's been, they've been doing it in Europe. They've been doing it in the Northeast and colder climates forever. And they're just basically taking that material, incinerating in a very controlled environment, emission-controlled environment, and then taking that heat energy and displacing fossil fuels. And that's what we decided to do. So I'm going to talk a little bit about how that came to be. But one of the first things we wanted to do is make sure this was going to fit in our community. Biomass does have a historical kind of connotation that folks may not feel as though is the right solution to burn it. And so we needed to make sure this was going to fit in our nice resort environment. And so we did an RFP. We selected Messersmith out of the Upper Peninsula of Michigan to be our vendor for the boiler systems, and we went back east and toured a dozen of these in very sensitive sites. Some of these pictures or these sites are what Tom said, so I'm just going to breeze through. But what I want you to recognize, these are on very sensitive sites. So this is a school site, right? 2 megawatt, that's what we're proposing. They have a very rudimentary emission control technology. It's just a multi-cyclone. Technology's come a long way from that. I'll speak a little bit more, but even with this, you can't see anything coming out of the stack. It's still very clean burn. They actually built another one 4 years later on the same campus because it was such a success. And so, surrounded by classrooms and ball fields and whatnot, they went ahead and did this, had no complaints. So it was a good site visit to see that. And then we saw one in the downtown area of Farmington, Maine. This one's 2.5 times the size of what we're proposing. Residential areas across the street. You can see little steam coming out of the stack there. That's just water vapor. This day happened to be about 2 degrees Fahrenheit out. There's water vapor coming out of your mouth when you breathe or talk. But that's it. No complaints. This tank here is huge. It's a backup 14,000 gallon propane tank that they would use if the wood energy facility wasn't able to fire for some reason. It's never gone down, but it's just a good visual of how much methane or propane or natural gas you're actually displacing with these systems. That's just 3 days. This thing was 70 feet long. So that's the reason I included it in the slide. So at the end of the day, you are having that impact as well. Again, downtown, trampolines and residential areas across the street. Here's one at a hospital. You can't really think of too much more sensitive site than a hospital. They actually strapped the steam stack, you can see that, to the hospital building itself. I joked with the guys there if they were able to double up the facility, the boiler unit as a crematorium as well. They didn't think that was very funny, but I did. But I'm glad you guys appreciate that. In any event, no problems on a hospital site, right? Chip bunker, just a big garage full of wood chips, very automated system with these augers. You can actually run these systems from your phone. Half an hour a day maybe of maintenance if you design it right. So the skill set that we have with our water plants and sewer lift stations and pumps and buried pipes is basically the same skill set it takes to run this plant. So we didn't need to hire some specialized folks to take it up. We got that right in our staff, which was a key thing of our scoping study. The ESP, or the electrostatic precipitator, is kind of your next level of defense against particulates after a multi-cyclone, if you were to go this route. We're actually utilizing what's called ceramic filtration with our project, which would negate the use of a multi-cyclone or an ESP. and it takes up to 99% of the particulate out, but also close to 90% of the NOx, which is really hard to achieve with any of these other systems. And in our particular air pollution control district, the NOx levels are very low, so they're happy to see us go through it. It's the first time ceramic filtration is going to be used with wood energy in the US. I think they did it in Japan, so but pretty excited about that. Buried insulated pipe, there it is on the left. It's not cheap, but you can push the heat about a mile and only lose 5% of your thermal energy. So that opens up the kind of windows of opportunities to connect into systems. In our case, we're going to be connecting into the Northstar Village and the associated adjacent rec centers with pools and spas. You can retrofit really old buildings. The picture on the right there is taken from the Holderness School that Tom had in his presentation. These are dorm buildings that are over 100 years old that are running on heat oil, and that is merely a file cabinet size heat exchanger that basically takes our hot water, interfaces with the cold water return of these systems, boosts it up so they don't have to burn the oil. In our case, they don't have to burn the natural gas. This is what it's going to look like. So they've come a long way. You don't have to look like a Pink Floyd album cover here. This is a CLT building that's being proposed for our system. You won't even see it from pretty much anywhere other than our driveway behind the fire station, one of our fire stations. Like I said, a 2 megawatt system. We're going to take down about 4,000 bone dry tons a year. Put that into perspective, the 25-mile radius of our location here probably produces in the neighborhood of 50 to 100,000 bone dry tons a year that needs a home to go to. So not going to take it all down, but it's a start. And there are other organizations in our neck of the woods that are looking at projects. So we will take more material than we produce within our district as part of that effort to create that sustainable offloading and disposal. A little bit of an overview. On the top of the map is where the plant will be. The yellow line is a buried insulated pipe in the roadway. We've just installed that this fall, and then we're connecting to the bottom there, which is the Northstar Village that consists of your standard multi-story ground floor commercial Beaver Creek or Val Whistler type village with all the pools and spas. About 1 million square feet of interior conditioned space. In 2021-22, that was a $500,000 natural gas bill that will be totally eradicated with this project. So material displacement of a fossil fuel with our project. Some studies, I won't go into these in detail. Tom kind of reviewed these in terms of the life cycle, the particulate difference, versus open pile burning, whatnot. In our case, our competitor is natural gas. If you're dealing with fuel oil or propane, the feedback or the ROI is better. This is a hyper volatile commodity. I mean, if someone maniac starts a war on the other side of the planet, the thing spikes. And so one of the nice things about hooking to a system like this is we can create a very stable, long-term, less volatile line item in your budgets for heating systems or heating energy because it's a locally produced byproduct. And by the way, you see it there, it's at 9. That was probably the peak. It subsequently had dropped to a 20-year low, and that was in the spring of this year. It's down around $2 a million BTU, which you might say was a bad timing for us when we're negotiating heat contracts with all the entities we're going to sell the heat to. But I looked at it as a good stress test to say, okay, how can we be competitive at really a historic low? It was so low that they stopped drilling. Like that, it won't go below that. They don't make money when it's at that level. So I feel pretty good about being able to be competitive with that commodity, given what we experienced there. So wood is good. That's the takeaway. It's not something that we need to be ashamed of. It's something that is like Tom said, it's part of the life cycle, carbon life cycle. It is renewable. There is no silver bullet today in terms of turning this material into pure carbon negative energy producing process. There are rocket scientists, believe it or not, today working on that. A company called Arbor, former SpaceX rocket scientists are trying to re-engineer the gasification. But right now, incineration in a controlled environment, putting that tried and true thermal energy to work in plants like ours, and it could be retrofitted into any kind of building where you have a good source of or a good need for heat is a very reliable way to go. So with that, I think we're ready for questions, if the audience might have any. I did want to say one more thing, because you had a question on costs, and so 2 megawatt, $500,000 a year in 21, $22 natural gas. Our plan is about $10 million in large numbers. And a good portion of that is the thermal distribution system, because we're a third of a mile away. So that's close to $1 million in piping that had to go in for that. So that drove it up. You can get closer to your end demand, you're better off. But we were able to successfully secure over about $5 million in grants. So and still pencil with the historic low in natural gas, but it does need that subsidy. But that's kind of the gross economics of our particular situation. The district's going to finance that gap, that $5 million. And our hope is to be able to utilize the net operating proceeds from this facility when our parcel tax that I previously mentioned sunsets in 8 years, to carry on the maintenance of the forest management work in our community in perpetuity while retiring the debt. So that's our kind of a macro goal there.
This may be a question for Julie or Tom, but can't we integrate these systems with production of biochar and then increase the benefit from a carbon life cycle perspective? I realize that reduces the efficiency some because you're leaving some wood on the table, but wood doesn't seem to be the limiting factor. And I do think carbon is our limiting factor. Is that being done anywhere? Is that a good idea, or does that make these systems less functional for what you described?
You probably have a perspective, as do I. So you go ahead.
So there are systems out there. I can think of at least 4 or 5 where they're doing the heat capture. In most cases where they're doing the heat capture from biochar production, it's going to some form of electric generation in those cases. So yeah, you can do that. I think the biggest problem right now is trying to find a reliable market for biochar. Like, there are certainly a lot of anecdotal testimonies to its benefit to the environment, and in small quantities you can find lots of it being sold. But if you want to go out and establish a marketplace, the numbers are all over the board as far as how do you get rid of it. In Colorado, there's a place that made biochar about 10 years ago, and you can come and get it if you want to. So I think that's the biggest issue. I mean, Paul alluded to it a little bit about there's technologies out there that you can do lots of things with this wood. Certainly you can make jet fuel with the wood, syngas, distill the syngas. The problem is the technology and the economics are not what I would call market ready, right? I mean, without tremendous subsidies, they just don't compete in the marketplace. Whereas wood energy, with natural gas, I'm pretty sure that it's not just $2 because there's a distribution cost added on.
Yeah, that's just the commodity rate.
I'm guessing closer to $5. This wood competes at $5 a million BTUs. If that's the retail value of gas at your doorstep, wood competes very well with that. And again, it depends on, whether it's, if you're trying to get rid of it and has a negative value. We do lots of projects where wood has a negative value, and then the payback is really good. But
one of the things we found too when we started looking at it, because that was our first thing, let's go for electricity and do biochar, and couple of hurdles there. One just, there's already a lot of renewable electrical energy in the grid. There is no renewable natural gas, literally or figuratively, in the pipeline. So in terms of taking down a fossil fuel, there's much bigger impact opportunity with that. And so that was one thing. Not that was a big goal, but we also have really crappy fuel. It's, the small diameter bark and lots of pine needles and just manzanita. It's not that hardwood chip that you might find in the European forest. So gasification really, they wanted more of a pellet, at least that technology that we were introduced to at the time. So we weren't comfortable going there. And our byproduct is ash. It's not biochar, but it still has value. In fact, there's a farming community just north of us will take, is going to come and take all the ash we produce for free, and they're stoked. And then there's an effort by UC Davis to look at potentially offsetting the fly ash in cement and concrete production with biomass ash too. So who knows? That's an opportunity that could really take down some carbon if that were the case. So good question though. Thanks.
Something I might say related to biochars, there is a carbon market for production of biochar right now, and some people are making that work, and they're typically tuning existing wood boiler systems to combust at a less efficient rate that doesn't take it all the way, and so you're left with char. And like Tom was saying, the challenge is finding a market for that then produced char. But we're watching that and exploring it. I also work with a lot of forest products manufacturers around the West, and a lot of them are struggling right now because housing markets are down, lumber markets are down, wood's not selling. They need to diversify their product line. A lot of them are already producing steam and heat for their processing, their dry kilns and that sort of thing. And we're looking at, one, could it make sense even to just add on a turbine to do power production as well, and or also add biochar production so you have that other diversified revenue stream coming in too. And the thing we keep on coming up against is who's going to take that char? So, and people, yeah, which is great. Yep.
And the technical assistance team will study, if you want to do biochar, we'll certainly take a look at it, but our eyes are wide open. Like we're not, we're constantly reviewing technologies from Europe, technologies from South America.
I will just say, in our forest district, they have bought biochar combustors, and they're going to start using them in the woods for burn piles. So if that's the competition, then the carbon balance of burning it for thermal is actually more carbon intensive, maybe, than burning it with an air curtain burner and putting the carbon right back into the forest soil.
Yeah, but again, then the difference there is useful heat. The difference is transportation and handling of the fuel versus getting the value of the heat that you're just letting go in the atmosphere, right? And those air curtain burners are not nearly as clean as the controlled combustion in that.
Correct.
So that's a trade-off too. So.
For Northstar, are you looking at snow melt at all as part of your district?
Yeah, that's still in the potential. Snow melt was the question, if we could put the energy to work in the snow melt, and it comes up a lot. We will have the opportunity to connect this system to snow melt in the Village Plaza. They don't have it today, but they need to re-engineer what they have there, and they're thinking about putting that in. One thing about snow melt is it's a massive energy draw. Like it will overwhelm the system, and nobody will get heat but the snow melt system because of the way those things run. But yeah, that's definitely a huge desire of the resort and the people that live there to get rid of all the noise that goes with snow removal and whatnot.
I think a follow-up question related to that is additional thermal storage. So would you be running your system year-round?
Yeah, we run it year-round. Obviously, the biggest demands are in the winter, but with those pool spots, domestic hot water, Truckee actually is a pretty cold place in the summer at night, and so there's a diurnal curve there. But we're looking at, we mined all the gas bills, and it's about a 70% turn down rate if you come off the peak of, call it January, February. So we'll still be running in a year-round mode, supplying that heat.
I was thinking, store, if you're running it year-round, your demand in the summer is in the spring, you can store some for example.
Well, it comes down to capacity. Like you can't thermally store over months in like thermal storage. So you'd have to have maybe a second system. They have a turn down rate where they operate efficiently. So if you sized it for the snow melt, then in the summer operation with one unit would not be practical, but you could put 2 units in, a smaller one and a larger one, and do that. And again, the interesting thing about snow melt is that we did this study, I think, on snow melt, and we love low temperature uses because then you can use ORC systems to generate electricity efficiently. But when you have a very, 100, even 140 degree, a small ORC system doesn't give you much electricity if the return water is 140 degrees. So we love 70, 80 degree return water temperatures and designing projects. So.
So I really think this is exciting to have a base load opportunity in this context, because as you grow, are you anticipating you're going to add renewables to the mix and use them for more wind blowing, sun shining days, and then have this be your base, or are you anticipating you'll develop more?
So the question was, would this be a base load? It sounds like you were talking about for electrical generation. We're only doing thermal heat, so we're not doing electricity. So this is purely heating load, so natural gas. Is our,
Will you diversify? I mean, as you grow, will you just continue to build?
I don't know. I can't speak for the future down that far, but I think, summits like this and conversations that are all happening here opens the eyes to all. And so, someone might say, hey, yeah, that we can diversify, we can do this over here, and that generation of thought will continue.
And I think, Tom, your company has worked with folks who've done sort of a portfolio of renewables on a campus, like not solely meeting the thermal energy need, but there might be
That's true.
solar incorporated.
Holderness replaced on their ice rink solar panels to get to their net zero, a big square footage of that. So yeah, a lot of projects that we've done are combined heat and power with wood energy. But again, and somebody mentioned that, I think, in one of the questions, but the cheapest energy and the most carbon effective or carbon neutral energy is the energy you don't use, right? I mean, so energy efficiency is where you're always trying to head on all these projects, and you want to keep that in mind when you do them. I mean, it's, like that's first, always.
And I'd like to just add that, everyone likes a silver bullet. There really isn't one right now. And, we have a problem today, like obviously with the air quality you're seeing here. And so the disposal is a massive problem within a problem. And, we were talking this morning about, or they were talking in one of the sessions this morning about this, what I'll call stacking of benefits. I think they had a different term, multi-value add or something like that. But, today we can take this technology, we can reduce the cost of disposal, we can therefore increase the scope and scale of our work that needs to be done. We can reduce particulate emissions through open pile burning. We can reduce methane from landfill decay and diversion. We can reduce trucking, like I said, one way 100 miles or up and over a 7,000 foot pass to get rid of this material. We can reduce the impacts to the forest floor, and we can take down a big chunk of a fossil fuel where there is no other way to do that. So those benefits stack today with existing technology, and if you're contemplating looking at doing something, this works. And so it may not be as sexy as some cool new gasification thing that may or may not work, but you can implement it today and make a lot of difference. So I'd like to add that.
Paul had a slide that I'm going to
Mike.
try to get. Mike, sorry.
It's okay.
Mike had a slide I'm going to try to get from him, and it's the one where he showed the foot of compacted material that they put on the forest floor to get rid of it. And I will guarantee you that there are more emissions from that as far as CO2 from that 1 foot over time as it decays, because there's going to be anaerobic and aerobic composting or digestion of that material, and it will emit more CO2 in its life of decay.
It actually dwarfs the
Burning.
reduction in trucking. The analysis that these guys did showed that the biggest benefit in terms of net reduction was getting things out of the landfill and out of the forest floor from methane production, which is saying something.
Other questions?
You guys showed, well, you showed that picture of this beautiful plant. And I guess my question really relates to the overall amount of space needed. It sounds like you guys are taking it from the forest, then you're processing it, turning it into the chips, then you're burning it for your boilers. What's your overall need for, for acreage or whatever to do something like that? Or is there an alternative where I'm from a really small town, Colorado. We're very site constrained. We're doing huge fuel reduction projects. And I love this concept, but I have nowhere. I might be able to sneak in a plant somewhere, but I can't sneak in a plant and stage the logs and ship them and do all of that.
So where are you staging the fuel reduction materials now?
Well, we're not. We're paying. We're working with Trout Unlimited. They're using some of the trees for stream bed stabilization. We're getting it hauled off at $30,000. For multiple days worth of trucks coming up to take it. We're trying to work with some organizations that take fuel to the reservations in the Southwest for firewood for elders and folks that need firewood. We don't know. We're trying to come up with that solution, and we plan on running this fuels reduction for the next 5 years, and that's our biggest stopping point is what do we do? We are going to do a bunch of open burning this year.
So the plant itself, probably 40 by 60, and then, you've still got to handle the material and get it from somewhere so you can stage it somewhere else and process it and bring it in by the truckload as it's ready or stored it's ready. There was a project in Austria that was really interesting. There were a village that the king had granted because of some war in 15-something, had granted the forest around the town to the town. And so by lots, they heated the whole town with a district heating system. But each resident of the town had to supply so many cords a year of wood. And so they drew lots every year, and somebody got the good land, somebody got the poor land, it was all over. And so they'd bring in all these in log form, they would stage it, then they'd bring in a chipper once a year and chip the whole year's worth of material. So, there's lots of creative ways. The St. Benedict's, got a chipper donated by somebody. Must have needed forgiveness, I don't know, but it was a big chipper, and they got 5 years worth of logs piled out behind their building that, dried and aged, and then they cycled those in. They were all hardwood logs. But
It's a good question. We were lucky in Truckee. We have the cap landfill transfer station where all the materials coming from the green bins and everything else, and they have the $1 million grinder there, and they have the trucks to transport the chip fans and all that stuff, and they manage those piles. That one shot I showed you of our parking lot stuff with the wood, that you can't just let it sit there. You got to be on top of that because they can create their own problems. And so that is an issue if you don't have that infrastructure already in place. How is that going to, how is your fuel supply going to work? It's a good question.
But we can help you suss that out, sort of site specific with our folks and with foresters that we might know in the area who might have some ideas about that. Some of our folks that we've worked with are not using their own self-generated wood. They're getting it as a byproduct from a mill who's producing sawdust. So that could be an option, is that you just have a supply contract with a mill that's delivering material to you. Or if you really want to be full circle about it and use material that you're generating from these thinning projects, you can talk to them about, staging your material there, ideally in whole log form, and chipping it sort of in succession. Another option that's a smaller footprint is a wood pellet system. That's not going to be, potentially you have a local pellet producer in your neck of the woods, and that would be supporting your local economy and forest management in a less very direct way, but it's still supporting it. And those pellet storage, that's in a vertical silo typically, which is a much smaller footprint than some of these systems that we've shown you. So that's absolutely an option as well. And it's likely that you're producing more biomass in your management work than you would actually need in your boiler, is my guess. It's probably like you're not even going to need that much. So you have a bigger problem probably, but this can help. This can be a niche to help use some of that.
Yeah, I think a good example of that's St. Paul, Minnesota. They have a district heating system that does combined heat and power there, where they have their staging. Again, it's dirtier fuel and it needs a more robust system to handle it. But you know, like we like nice clean wood chips for designing equipment, but that's not what we get.
We're getting the hook. Thanks so much for your engagement and your questions.
Appreciate it.